a research facility gauging its notable potential against huge dangers. Information from space examiners suggests that if Safe Haven succeeds, we could see a 30% increase in Earth's monitoring capabilities within the next 5 years, which could transform disaster response, agriculture, and resource management worldwide. Dr. Elaine Rivera, a senior scientist at the Global Space Policy Organization, notes that Safe Haven's capabilities could revolutionize how we monitor climate, predict natural disasters days in advance, and save countless lives. On the medical front, the genetics lab on board Safe Haven might enable breakthroughs in combating degenerative diseases, potentially leading to treatments worth billions of dollars annually. However, a misstep could have equally far-reaching consequences. Dr. Alan Roth, an aerospace engineer with the Global Space Alliance, warns that relying on AI-controlled systems in such a critical environment is unprecedented and could lead to cascading failures if even a minor error occurs. Roth stresses that a single failure in Safe Haven's automated systems could create a chain reaction, endangering astronauts and halting ongoing research. In a worst-case scenario, Safe Haven's AI could misinterpret data in a way that necessitates a full mission shutdown, hindering space research and risking lives. Predictions about broader societal impacts are similarly complex. A successful Safe Haven mission could drive interest in AI and space research, sparking a new wave of technological advancements across industries. However, success on this scale also raises ethical concerns about surveillance capabilities and privacy, especially as space agencies and private firms share an unprecedented amount of data. Moreover, experts caution that unforeseen outcomes could arise. Increased reliance on AI could lead to critical vulnerabilities, or new discoveries in space could reshape health industries, fueling debates on access and ethics. Part 6: The Edge of Discovery. Questions and Possibilities. With Safe Haven operational in the future, the stage is set for both groundbreaking discoveries and unanticipated challenges. Scientists are on the brink of new knowledge that could redefine our understanding of space's effects on human biology. However, there's a catch. Initial readings from Safe Haven's genetics lab have shown unexpected fluctuations, leaving experts scrambling to determine if these are early breakthroughs or troubling anomalies. Could this be the beginning of a new scientific era, or are we seeing hints of deeper, unsettling issues? Meanwhile, Safe Haven's AI-driven systems, responsible for maintaining life support and environmental controls, have been performing well under pressure. Nevertheless, NASA engineers are closely monitoring for even the slightest inconsistency, knowing that a single mistake could mean catastrophe. So far, the AI has shown remarkable resilience, adapting to slight atmospheric changes with precision. Yet, every decision made by this system now raises a critical question: can we continue to entrust our most advanced missions to a technology that even experts admit they don't fully understand? As the module pushes the boundaries of exploration, new obstacles arise. Cosmic radiation levels have risen unexpectedly, pressing scientists to find ways to reinforce the module's shielding. The team has proposed a potential workaround involving magnetic fields, a concept that, if successful, could revolutionize future space travel. However, the risks are significant, and failure here could expose astronauts to dangerous levels of radiation. The Safe Haven mission teeters on a knife's edge, where every new insight reveals both a glimpse of progress and a potential threat. With critical decisions ahead, the next steps promise discoveries that could either bring us closer to answers or plunge us deeper into the unknown. Part 7: Challenges on the Horizon. As NASA's Safe Haven Orbital Lab embarks on this groundbreaking mission, several obstacles threaten its success. One of the biggest challenges lies in the political landscape. Countries around the world are vying for dominance in space, with several rivals viewing NASA's advancements as a direct threat. This has sparked debates about resource allocation and competition for orbital real estate, creating potential tensions that could affect international cooperation on future projects. Yet, this competition may also inspire unexpected alliances as spacefaring nations recognize the benefits of shared knowledge and resources in such high-stakes missions. Technical hurdles are equally pressing. Safe Haven's reliance on advanced AI for mission-critical functions presents a level of risk never before attempted on this scale. Engineers are racing against the clock to refine safeguards and ensure the AI can adapt to unpredictable conditions in space. This pressure has driven NASA to explore innovative solutions, possibly unlocking new technologies that could shape the future of autonomous space exploration. Budget constraints add another layer of difficulty, with each new development adding millions to an already stretched budget. While these limitations may seem restrictive, they've also driven NASA to collaborate with private companies in groundbreaking ways, fostering innovations that might not have emerged otherwise. These partnerships could set a new standard for collaboration between public agencies and private space ventures. However, with these challenges mounting, one question looms larger than ever: can Safe Haven overcome these obstacles to unlock the mysteries of deep space, or will these hurdles be the undoing of one of NASA's most ambitious projects yet? And with that, we leave the mission's fate undecided. Will NASA's efforts reshape our future or reveal that the universe is wilder than we ever imagined? Hit like and subscribe to stay tuned for updates on this historic venture, where every discovery could change life as we know it. The story is far from over, and the stakes have never been higher. Subatomic changes at the cell level continuously. This innovation will be significant in concentrating on how drawn-out openness to space affects the human body. This is critical as we look toward longer missions. Unlike any previous ISS version, Sanctuary is furnished with radiation-safeguarded chambers designed to protect both astronauts and sensitive equipment from space's most dangerous rays. Interestingly, astronauts can work in an environment where radiation levels are carefully controlled, enabling longer and safer mission durations. However, the advancements don't stop at science. This module offers remarkable onboard comforts, from sleep cases tailored to counter zero-gravity stress to adaptive lighting that regulates astronauts' circadian rhythms. These small luxuries aren't just for comfort, they are key to reducing the mental and physical toll of extended missions in space. Yet, perhaps the most groundbreaking addition is Sanctuary's AI-driven system, specifically built to monitor and adapt the module's environment in real time. From predicting potential hazards to adjusting oxygen levels, this AI acts as a silent partner in every mission. However, there's a catch. With all these state-of-the-art features comes an equally high level of risk. Can Sanctuary handle the intensity of deep space, or will this leap in technology expose astronauts to unforeseen dangers? NASA's Sanctuary Orbital Lab is more than just a leap in technology, it's a move that could redefine humanity's relationship with space. Its impacts extend from orbit to daily life on Earth. This groundbreaking module has given researchers a glimpse into how space advancements can benefit global health, climate science, and even cybersecurity. For example, the Advanced Genetics Lab could uncover new treatments for diseases by studying how human cells respond to prolonged space exposure, potentially transforming healthcare on Earth. On a broader scale, Sanctuary's enhanced Earth monitoring systems are designed to track environmental changes with unparalleled precision, potentially providing critical real-time data on climate shifts. This technology could revolutionize disaster prediction, offering earlier warnings about extreme weather events, saving lives, and preserving resources globally. However, it's not all opportunity without risk. Sanctuary's AI system, a marvel in autonomous tech, raises questions about reliance on artificial intelligence in high-stakes environments. If this system fails or is breached, the safety of astronauts and even Earth-based systems connected to it could be jeopardized. This module represents the first time such AI has been tasked with life-supporting functions in space. Experts warn that any glitch or interference could lead to dire consequences. These advancements have drawn extraordinary partnerships between NASA, tech giants, and international space agencies, uniting them in a race to push human capabilities beyond Earth's boundaries. Chapter 3: The High Stakes of Humanity's Frontier. NASA's Sanctuary Orbital Lab represents a pivotal moment that could reshape our future. Success would mean new frontiers in medicine, environmental security, and space exploration. Insights from zero-gravity research could lead to treatments for diseases once thought incurable, while environmental data from space could enable us to predict and mitigate climate disasters with newfound accuracy. This technology has the potential to improve life on Earth and expand humanity's reach beyond our planet. Yet, if Sanctuary falters, the consequences could set space exploration back by decades. A glitch in this high-stakes module wouldn't just endanger the lives of astronauts but could also force us to question the limits of autonomous systems and AI in life-critical conditions. The trust we are placing in technology like this is unprecedented, and a setback could cast a long shadow over future missions. Moreover, Sanctuary's success would set new ethical standards around data security and privacy, impacting not just astronauts but also citizens on Earth. With its constant environmental monitoring and AI-driven decision-making, this module is pushing boundaries between global health and individual privacy rights. If this mission redefines collaboration between private companies and global powers, it also establishes new layers of responsibility for our shared future. Chapter 4: Expert Analysis and Future Projections. Experts are closely analyzing NASA's Sanctuary Orbital Lab to understand its implications for the future of space exploration and Earth-based applications. NASA has recently uncovered another expansion to the worldwide space station, and specialists are calling it quite possibly one of the most advanced modules ever built. However, this isn't just about breaking mechanical boundaries. There's a twist here that could redefine our thoughts about space exploration and what it means for life back on Earth. Imagine a future where what happens many miles above our heads could alter the way we tackle problems on the ground, from climate monitoring to global communication innovations. Here's the truth: NASA's latest ISS module isn't simply designed to enhance space research, it could change everything. And this advancement isn't happening in isolation. It's unfolding during a time of heightened tensions in space exploration, with global powers and private companies racing to establish dominance in space. Why does this matter now? Because the stakes are higher than ever, and what's inside this module could shape our future, whether we're ready for it or not. The latest addition to the ISS is more than a module. It's a bold statement about the future. What's at stake is nothing short of our role in space and our ability to harness technology to confront unprecedented challenges here on Earth. Stay with us as we unpack the mystery and reasoning behind NASA's latest move and why it might just take your breath away. Part 1: A Turning Point in Space Exploration. This latest ISS module isn't just an engineering marvel, it's the culmination of decades of breakthroughs, challenges, and perhaps some unsettling questions. For years, space agencies like NASA and private giants like SpaceX have been pushing the boundaries of human ingenuity to establish a permanent foothold in space. Yet, alongside these advancements, a new era of space risks has quietly emerged. Just a few years ago, concerns about overcrowding in Earth's orbit grew as satellites and debris began to cluster in alarming numbers, raising fears about catastrophic collisions. NASA's scientists have warned about the Kessler syndrome, a chain reaction of orbital crashes that could render areas of space unusable. This new module, while groundbreaking, is designed with more than just research in mind. It must also contend with a highly volatile environment where even minor miscalculations could threaten the ISS itself. NASA and its partners have developed this module to navigate a growing list of threats, rising tensions with other spacefaring nations, unpredictable cosmic events, and even the potential for man-made disasters. But why now? Because time may be running out as countries ramp up their efforts to dominate space. This module represents both a safeguard and a gamble. The truth is, no one knows for sure what lies ahead. This advancement may be NASA's greatest leap yet, but could it also be their riskiest move? The answer may lie in an unexpected twist that could forever change how we view space exploration. Part 2: The ISS Module Redefining Space Innovation. NASA's latest module, known as the Haven Orbital Laboratory, is unlike anything we've seen before. It's not just an expansion of the worldwide space station, it's a complete reimagining of what a space module can be. While past modules focused primarily on functionality and survival, Haven is equipped with cutting-edge specialized facilities that will allow astronauts to conduct advanced experiments with unmatched precision and control. Inside the module are next-generation labs dedicated to genetics, physics, and deep space simulation equipment so advanced it can detect